Yeah, we're ready.
Okay, well, I think you're all very brave coming out first just to see me anyway in the first place, but secondly to brave all this weather that we're about to get. Hopefully it won't get too bad before we go home. I'll talk a little bit first about, I don't actually know why I got caught for this, but I'll talk a bit about my experience of test flying and gliding. I think probably like everything else in gliding I've ever done, it's not been as a result of anything I know or can do. It's been a result of being in the wrong place at the wrong time. And I never really ever thought about being asked to do any test flying of anything. I thought I was in enough difficulty sort of flying anyway without testing things. However, it all started really when I started working for Lasham full time. And Gordon, who was the then engineer, said to me, I can't do all the test flying because I've done all the work on the gliders, and there was policy then, rightly so, to test fly the club gliders after they have come out of annual or major work. So I get caught for that, which was good because it taught me a little bit about how to be analytical when you're flying. It also taught me to fly the gliders on the edge of the flight envelope or within the flight envelope, but to explore the flight envelope, which is an important part about test flying. And I did have a couple of little incidents whilst doing it. Probably the worst, I just pulled off aerotone, a little Grob 102, and suddenly found myself with incredible stinging in my eyes and couldn't see anything. I thought, this isn't right. And it was only after a little while that I realised the compass had exploded. In all the compass fluid had been blown back by the vent straight into my face. And bearing in mind I was now at 3,000 feet, a few miles from the airfield, and couldn't actually see at all. It was a little bit of fortunately I got enough sight back in one eye to squint my way back to Lasham and around the circuit and do a pretty not very good landing and run to the bathroom and wash it all out. So there was a lesson there. And that was probably the worst incident I've had actually whilst test flying things. Later on, and I'm using this, oh, that didn't work. Next slide, please. I'm using this as a thing to remind me really what to say, because I'll forget otherwise. The pictures aren't important. You've all seen this. We unfortunately damaged the original propeller on this delaminating. We had to fit a new prop. Part of that process was to submit a test program to the LAA, and I spoke to the LAA, said, well, you need someone to test fly it. And I said, right, well, who can do that? Well, you need someone who's got a SLMG rating for a start and all the rest of it and experience. I said, well, why don't you do it yourself? You've got all the requirements. So I did. So that was my first formal bit of test flying, and that I had to again analyse the performance of the aircraft with the new propeller. And thanks to Julian's fantastic little bit of logging equipment, we actually provided the LAA with a very accurate graph of rates of climb and speeds and all the rest of it. So it was really good. But that taught me about recording stuff and about, again, being accurate and analytical and not trying to, how shall I say, don't let the desire to get the thing through the test cloud your judgment. I think that's the important thing with all of this. So anyway, that all worked well. And the next thing, having submitted that and said thanks for the, good, approved, all done, the next thing that happens is that the good old LAA ring me up and they said, oh, we've got someone, and you all know David Shrimpton, who has got one of these. We want to get this, or he wants it put on the LAA. oh, right, good. You're going to test fly it. Oh, thank you very much. So once again, so this is not a, this is a more complex thing because this is now a type approval for the LAA. So you've got a list of criteria you've got to go through to test fly this thing, which I have to say was the weirdest thing I've ever flown. It is a bit like sitting in a glider, in a probably in a K8 or something with two Lambrettas on your lap. The noise is unbelievable. But anyway, I managed to record all the necessary data and fly it, spin it, install in all the spinning stuff and record everything and obviously come up with some faults which had to be rectified before we could then submit to the LAA, and finally he got the approval. So that was another learning curve for me, because again, I hadn't done anything like this before, so it was all completely new. But it's just about learning to be analytical. So go to the next one, which will remind me of what I was going to say. Oh yes, this was another experience, another LAA type. This was just a permit test I did for somebody. And there was another lesson to learn here. The criteria for all these things, it's got a placard in it, it's got all the speeds on it, fine, so you check that, it's got that. You check the ASI is marked with the speeds, fine. Better to read the flight manual before you fly it. So off I go, gear up, VNE, mega aileron flutter, which is like, oh, that's not very nice. And I don't know if anyone here has experienced that, but you have to slow down well below the speed at which it started before it will stop. Fortunately it did, took it back, ailerons got a little bit of play in it, but not a lot. You wouldn't expect it to cause that amount of trouble. So we start looking at it and looking very carefully, looking through, and I said, check these speeds. So we looked at the speed, it was in miles an hour, but so was the ASI, so it should have been right. Go to the flight manual, different speeds. So I was like 10% over VNE. And for years and years it had been wrongly placarded. So rule one, if you're going to test fly something, if it's got one, read the flight manual. Another lesson, good lesson. My fault entirely, but it's yeah. The flight manual might not be everything, but it certainly would have avoided that experience. Maybe there was a little bit of problem with the aileron, but that wasn't the cause of the incident. So there we are, a little bit of learning. And I also, which Graham here knows a little bit about, I've test flown one of these for a permit test as well and failed it because it refused to climb. Yeah, exactly. Well, that's exactly what I said to the LAA. I sent the figures back and they said, well, it doesn't climb well enough. I know. What do you expect me to do about it? I'm only testing it and reporting. I'm not here to rectify the fault. I'm just telling you what's wrong with it. You know, it's failed. But there we are, because it doesn't actually meet the criteria of the LAA's minimum rate of climb. So there we are. So we sorted it in the end by some modifications being done. But anyway, that's another story. But so another experience about why it is important to be analytical and say, if there is a problem, you've got to sort it, not just tick the box. But that is departed from Booker now. And in fact, when I flew it from Booker to Popham for the chap to move it, I got a call from Booker Tower saying it was all right to climb now, just after I departed. Which I thought was a bit sarky. So on to the TG3, and this is really, I guess, probably the most scary, well, not necessarily most scary, it didn't turn out to be scary, but the most challenging thing, because Gordon and Howard seemed to think that I was the right person to do this. I have no idea why, because once again, probably in the wrong place at the wrong time. Yeah, mainly to stay, so they didn't have to fly it. So I had a bit of some technical tuition from Howard, which a lot of us, I have to say, because he's got the brain the size of a planet. And unfortunately I haven't, which is probably why I'm doing the test fly. But one of the things we thought, from my experience, obviously there's certain criteria, but first of all we've got to just fly it and see what's wrong with it, but then we've got to see if it will meet certain criteria. Well, we did have a flight manual for it, and we've got a very comprehensive maintenance manual and a reasonably comprehensive flight manual, which gives you all the speeds, weight and balance, a lot of information. It also tells you sort of things which are somewhat surprising, like it can be flown, it can be spun, it can be aerobated, and it can be flown upside down. Not with me in it, it can't, but I find that unlikely, and I don't think we will be doing that with it. But yeah, the flight manual is, I think, optimistic, to put it politely, but it was a military glider. One of the reasons we've had to test fly it is because it was never, I don't know if they were ever flown over here in the wartime, probably not, but it was only ever a military type in the USA, so it never got on a British register. It was never a BGA approved type, so there is no type certificate holder for it, so we basically have to prove that it's an airworthy glider or an airworthy type to get a BGA C of A, which is fine. And as someone said, the BGA haven't had to do that for a long time because the way things work now is a little different. So, as I say, we had a manual for it, which is great because we can read that and we can get some idea. And there were some things in there that it said, some quite good things that said weight and balance is not particularly critical. Well, that's a bit of a vague statement. However, in the maintenance manual we did find a weight and balance schedule, and of course before you get in any glider, as you all know, it's dead critical to make sure that you're within the weight and balance range. Bearing in mind we've got to do a number of spinning or stalling manoeuvres in it, the good thing to do is start with a forward C of G, which is safe, and gradually work back to the aft C of G limit. So the first flights were done with a well forward C of G, but I'll come on to that in a minute. So eventually, after everybody at the BGA looked at it and did an engineering assessment on it, they gave us a permit to fly, which unfortunately has got my name on it, which is not very good, but it says I'm the one that's got to do it. So anyway, they gave it a permit to fly, and because Gary had done a huge amount of work on it, along with Ed, the BGA relented and let Gary do the first flight on it, which is great. You know, he's fine, and he obviously, perhaps not been quite so analytical, pointed out a few things, but obviously when I went to fly I found a few more things. We'll go on to the weight and balance now, because someone was asking me about that earlier. When we started looking at the weight and balance and we weighed it, we realised that glider is already, before we start, the empty weight is considerably more than the empty weight given in the flight manual. So when they were manufactured, they were coming out at about 750 pounds allegedly, which I find surprising. Ours comes out at 876 pounds. Well, obviously the max all up weight is the max all up weight. So that leaves us a bit of a problem, because as you will see from the placard on the right, it gets to the point where the in order to get the balance right, the max rear seat weight crosses over the max all up weight, so you end up, you can't put two heavy people in it, which is a bit of a nuisance really. So if you go beyond that point, if you put someone heavy in the front, you've got to put someone heavier in the back, or you put someone heavy in the back, you've got to put someone even heavier in the front to compensate, because the rear seat is behind the CFG, which is quite unusual these days, but it's a long way behind the CFG in this. So the more you put in the back, the more you got to put in the front, which means that you then approach your all up weight. One thing we haven't got, for those who know about these things, with modern gliders, we have a thing, non-lifting components weight maximum, which is everything except the wings. We have no information on that at all, so that's just hope for the best. You no idea what that would be, but I guess they are the opinion, and looking at the wings, I should imagine they're plenty strong enough for any load you can put in the fuselage. As you probably know by just looking at the aeroplane, I consider it so. Looks like a powered aeroplane without an engine, to be quite honest. And I was expecting before I flew it that it would probably fly like a powered aeroplane without an engine. However, we'll move on. So weight and balance is dead critical, but one of the things we are looking at is trying to find a few areas we can lose some weight, and secondly, Howard is actually happier to give it, once we've done all the testing and got it approved, to give it a extension on the max all up weight, which will give us a bit more tolerance for flying nearer normal people in it. At the moment there's about 3 or 4 people in this room that could fly it. Well, yes, but they had another 120 pounds to play with. If it genuinely was 750 pounds when it came out of the factory, this is the whole point. You see, we're short of max all up weight, because if you had another 150 pounds, you could put more in the front and more in the back. But any glider where the rear seat is a long way behind the CFG creates a problem immediately, because you've got to balance it with a heavier person in the front. So that is always going to be a problem. So we studied this, or I studied this pretty carefully before we went. As I was the one that weighed it and did this, I wanted to be pretty sure that before I got in it that it wasn't going to do anything stupid. We had a placard originally, not a lot to go on there, but there are some numbers in there, and they're in miles an hour, being American. And that was quite useful, because one of the things, not only on the placard it mentioned, but the other thing we found in the manual was some stuff about aerotowing speeds. Not just maximum speed, but optimum speeds, which was quite useful. And I'll come back to that in a minute. But yes, that was a placard that we found in it. But you can see this placard doesn't give a huge amount of range on the weight. It's not brilliant, which indicates that it already was overweight in the past. So to test flying these days, we have a set of criteria, CS22. Now that generally was written a long time after this was built, and it's interesting that trying to test to this standard, where standards have improved considerably, there are areas where it starts to be perhaps get a bit marginal, because these criteria are considerably stronger criteria than they would have used, particularly in a military spec aircraft 80 years ago. So but this is the criteria which we're testing to, and there's pages of this. I'm going to show you all of it, but this is the front of it, and the information this gives you, and it gives you certain criteria which it's got to meet. Obviously handling, stalling, spinning, controllability on landing, all that sort of stuff, effectiveness of spoilers, and even mentions glide performance in here, so that's interesting. So we'll move on. Gary on his first flight mentioned that the hook was very sensitive to release. So this is a Schweitzer hook, which is an American hook and is still in use in America in some gliders. And amazingly, we were permitted to keep using this. We have to have special rings that go in it. We can't use TOS rings on there. We use Schweitzer rings. So we've got a strop, and all that happens, that little bit at the back just goes back and releases it. It comes off. Now I wouldn't want to use it for winch launching. Not that the glider is approved for winch launching. Very simple and effective, but unfortunately it was hair sensitive, so that you could sneeze at that. And my fear was that if you actually overran the rope, it would drop off in flight. If you got a bow in the rope, it would come off, which could really spoil your day if it was at the wrong time. So that's one of the little things we found out. That was one of the fixes we had to do, and we actually cured the problem by putting a stronger spring on it, basically. Quite simple. And some of my test flying, I deliberately got a bow in the rope just to make sure that it doesn't come off when that happens. And that seems to be all right, but I didn't do that until we got to safe height, funny enough. So yeah, that works quite well now, but it's a bit different from what you're used to seeing. The other thing you'll notice is the control surfaces are a bit odd the way they're mounted. They've got widening slots. Now nobody seems to, there's various theories that it might reduce the forces on the controls, but nobody seems to be able to give us a definitive answer on that. There's somewhere you can sit at the front if you want. Mind the wires. Yeah, nobody seems to be able to, all the boffins don't seem to be able to give me a straight answer on this as to why these are here, these tapered joints. But the thought is it tends to reduce load on the control surfaces. And you'll see it's got the same thing on the rudder, which is even weirder. Yeah, and we know this isn't some sort of Graham.
Whether the flying example in the States has got
Yeah, we've looked at the pictures. Yeah, because we thought someone done something to this. Yeah. So yeah, it's all a bit weird that. We don't know why it's done, but we're not about to change anything, obviously. So we'll come back to that in a minute, but there's a picture of the ailerons. So they're quite similar to a lot of older gliders. They're split ailerons, which allows for the wing to flex without causing problems. Two separate cable drives, but there's no differential between the outer and inner aileron. They both move at the same rate. There is a bit of differential on the ailerons, but not a lot between up and down. And the drive linkage is very crude, and it runs around a lot of nasty sharp angles with pulleys and things. So one of the things we found that the aileron loads are quite high, and it's not. It's partly mechanical, and it's partly the sheer size of the things. Yeah, that is one of the features of it. But they're no worse than something like a T21, to be quite honest. If you fly a T21 a bit fast or on aerotow, the aileron loads can be quite heavy. And if you fly like I do a Sky with massive ailerons, again the forces are quite high. So with older gliders, they're not terrible, but they are.
Was it designed to have heavy loads to mimic what the...
Well, this is a possibility, a distinct possibility. It might just be that all gliders were like that then. It's just, yeah, some of the some of the American gliders are a lot cruder than the German and European gliders of the same era.
I see the merchant guys, the wacky
Yeah,
guys
yeah,
that
yeah,
they were training for.
yeah. It's a good. I mean, the whole thing. It was a training glider designed for flying the big ones. So yes, obviously it is built like a tank. But I'll go. That brings me to the next thing, really. Being built like a tank, you'd think there'd be loads of room. I'm sorry, this is slightly out of focus. This I must have moved when I took this, but you'd think that being so large and built like a tank, there'll be loads of room in it. But in the front seat, actually, it's a bit tight in length. There's plenty of width and plenty of height, but I'm very tight with my legs under the panel. You sit very high, but it's tight for space, which is a bit strange, really, but there we are. But having said that, you get a very good view because the panel's low down, so you can see what's going on in the world, and you can certainly see the ground when it's coming up. So first flights, we've got our list of criteria and things we want to do, but for the very first flight, we've just got to get used to how it flies, how everything works. No big deal about getting measurements, just sort of investigate stalling speeds, basic handling, and how things work. Well, the first thing I noticed is, well, on the first flight I actually asked the tug pilot to tow at sort of about 55 knots, which we thought might be reasonable, because the manual says minimum comfortable towing speed is about 60 miles an hour, so we thought 55 knots. So I'm going along behind the tug who's doing 55 knots, and I'm in radio contact, fortunately, and I'd previously also asked him to vary the speed in the climb, so we slow down, see what happens, speed up, see what happens. Well, I'm getting about 40 knots in the aeroplane, so there's something wrong immediately with the speed indications. Anyway, as predicted, he slowed down to 50 knots and the glider becomes pretty much uncontrollable. We start to get real problems holding it in roll. So rapidly speed up in a hurry. All the way up to 70 knots indicated in the tug, no problem, it flies fine. Brilliant, which is 78 is max towing speed, I think. It's no problem. So interestingly, it's actually capable of being towed at quite high speeds, which might point to the type of aeroplanes that were towing it at the time. It's very likely quite big, powerful American things, you know. And so they've, yeah. So interesting, unlike a lot of the older gliders that we fly here, it's actually quite capable of towing at reasonably high speeds, which is good, and it's more comfortable at the higher speeds, which was a bit of a surprise actually, but anyway. And interestingly, the ailerons, although they're heavy, at the higher speeds they work more effectively, so you don't have to move them so much. So it's actually a much better experience. If you fly slowly, you're doing all this all the time, and your arm starts to ache fairly quickly. Yeah, it gets a bit hard work. But anyway, yeah, so that was the experience with aero towing. And the first flight, stalling speed, well, we don't know what that was because the airspeed by the time we get near the stall is now reading 0, so that's obviously not right. The other thing we found on the first flight, that you pretty nearly couldn't move the spoilers. You'll see the blue T handle on the left. Well, that wasn't like that, it had a round knob originally. So obviously approach and landing's fine, but I could only get about a quarter of the spoilers out, but it didn't seem to cause a problem because it doesn't glide that well anyway, and a little bit of side slips, not a problem. So we thought we'd look at these things. So first thing we did was fix the pitot by extending it forward quite a bit, and that has got us reading pretty much the same speeds as a tug now, though we've still got a few issues with that in that it's incredibly sensitive to yaw. So what we're going to do is try, oh, go away. we're going to try, no! We're going to try a boring and rigging a T21 or T31 type pitot on it, see how that goes. Not convinced the pito's in a good position still. It's fairly, it might be to do with the static positions as well, but a very slightest bit of yaw and the SB just has nothing. So that's a little bit wrong, that.
Have you tried asking the States?
Yeah, they've got different pitots on all of them by the looks of it. Doesn't really help us very much.
The one at the WAM Museum is identical.
Yeah, yeah. But some of the others have got a much bigger diameter tube hanging out the front, but I guess they've all got a problem.
Have you tried cockpit static?
No, not yet, actually. That's another thing we can try. But yeah, we've got to do some more experiments with that. It's usable, but it's a nuisance, you know. You slightest bit of yaw and you suddenly got no speed. I mean, I know you get it. If you excessive amount of yaw, you would expect that, but not. It's too sensitive.
I noticed the release knob is round, so CS22 jar 22 states it should be T hand.
Yes.
Blue.
Yes.
But you know, that's the
Awesome.
importance for you.
Yeah, yeah. Engineering assessment wasn't my department. Tell Howard that one. But the release knob is not the issue, it's the other one. So the other one had a blue round knob. I'll come on to that. That was the next problem we had to solve. So we decided to have another look at the linkages as well, only to find that having had two inspectors, the BGA Chief Technical Officer and Howard de Rode, all go over it with a fine-tooth comb, all managed to miss the fact that the cable from the front spoiler control, was wrapped round one of the steel tube members of the glider, which, until we ripped all the seats out and tried to look at how we could improve the situation, we didn't find that. So not only was it trying to wear its way through the aeroplane, but it was also pulling at a ridiculously bad angle. So having fixed that and put a T-handle on it, you can actually now open the spoilers. So that was, this is what I would call teething troubles, things to fix at the beginning. But this is very basic stuff, but it's still got to be sorted. So having got over the mechanical defects, we then actually start to look at the things that we've got to measure. Now, if you look at CS22, we've got to measure stick or elevator positions, not stick position, but it's elevator position at different speeds with different weights. So through the program, we had to fly max forward, max aft, and mid CFG, max all up weight. So we had to ballast the glider. And how do you measure the elevator position in flight? Well, the only way you can do it is have a stick which you put in a position against the panel and mark the position of the stick on your ruler effectively, and then measure where the elevator is after you've landed. So you fly at different speeds trying to hold the stick, and it's the trimmer, unfortunately, once you get at the higher speeds, it runs out of trim fairly quickly. So you've got to try and hold. No! I'm going to put you on flight mode. Excuse me, chaps. Put it on flight mode. It won't keep doing that then, will it? Sorry?
Hour off.
Yeah. So you've got to try and fly the glider at a given speed. Bearing in mind they won't give me a 2-seat permit until we've done quite a lot of this testing, so I've got to do it on my own, single seat. So I've got to fly the glider at different speeds and mark on my little bit of wood where the stick is, which is quite tricky when you start doing higher speeds because you've got to try and hold the stick still and mark it. It's all a bit entertaining. So that was a bit sporting.
Is there a risk that the loads on the ailerons sorry, on the elevators at high speed will stretch the cables, or there'll be some play in the system so that there's a
stick position. Yeah.
when loaded compared with static.
Yes, but that's why we're flying it. Yeah. Oh, what you're saying is the elevator may not be in the same position.
Yeah, exactly.
Well, you can get around that by pushing it on the elevator.
Oh,
So when the elevator's in the up position, you pull it down against the stick. Yeah, that's so. Then when you've landed, then you've got to put a clinometer on the elevator with the stick in the positions you want, which then against your measuring stick that you marked when you were up there, which was that was the hard bit actually, is getting the measurements. Because when you start flying at higher speeds, you don't get a lot of time either. The ground starts doing that. Its rate of descent at high speeds is pretty rapid. But what I did discover early on, fortunately, it does soar well. It climbs really well in thermals, and it's really controllable as well in thermals. So that's quite handy when you're trying to do your test flying and you've burnt off 2,000 feet in about 2 minutes. You can actually climb up again and have another go. So yeah, it does actually soar reasonably well, and its actual rate of sink is not horrendous if you fly it slow enough. And amazingly, although it flies at reasonably high speeds, your stalling speed is under 30 knots, and you can actually fly it round at 35 knots in thermals very comfortably and well controllably, which is nice because it does mean that you can climb well. It's not a problem. For what looks like quite a chunky old glider, but unfortunately when you want to get to the next thermal, that's where the trouble starts. You don't want to try and do that in a hurry. But it's no worse than a T21. It's probably better actually, I think, probably a little bit faster. Right, we'll move on a slide now. But as I say, the cockpit was a little bit disappointing for such a big glider. So that's just that was just to remind me of the jobs we had to do. So we had to do a worksheet and submit it to Howard for the changes we made on the things. That is the chart we ended up with, elevator positions and speeds, which for anyone who knows what they're looking at might raise a few questions, because one of the things that Howard came up with is that whilst you expect that the position to not be linear, Howard became a little bit concerned that we need a lot of forward or down elevator to reach the higher speeds. And we was concerned that we would run out, but in fact we don't, because you've got like 30 degrees of down elevator, so we don't use that. But Howard was concerned at the rate at which the down elevator was increasing with the higher speeds.
Sounds like you do have the ability to put some heavier people in the front.
Don't forget that bottom one is with aft CFG position. So yeah, with forward CFG position, things are a little different, obviously. But we didn't get to 80 knots to measure it because I had no way of holding a stick firm enough to hold 80 knots for long enough to measure it on my own. So we had to do it with two people. It was easy, because you can get someone to fly it and you can measure it. So we never got the measurements up to VNE with just one person in it. You just couldn't do it because the ground was getting in the way too quick. But interesting. But anyway, that's what we had to come up with. So it's as I say, that was probably one of the more difficult things, was to actually get the measurements, and we had several goes at that, and until we got the same results a few times, we didn't sort of record it. Yeah, elevator forces is the other one. So we've got to do a similar thing with elevator forces. There's all sorts of things. That fortunately is easier with modern equipment, because now we've got these like you can get these spring balances that fishermen things use, which are digital electronic. It makes it really easy because you can hook that on a stick and do that or do that, and get a digital readout of the loads. So that actually is great because that gives you a really easy way of recording that information. So you've got to record the stick forces. So that wasn't actually as difficult as all that compared with the other things we had to do. But I guess also if you were really clever with measuring the elevator position, if you could do it with telemetry, if you had the right equipment, so you could have some sort of transmitter on the elevator with a readout, but was way too clever for us. But that is one of the things we had to do. Then it came on to stalling and spinning. I think that that's the criteria. One of the things we found out, or I found out, is that when you bring it to the stall, there's very, very little stall buffet, which is one of the things I like to see, which doesn't give you a lot of warning. It's not sharp or abrupt stall. It's a bit like a K21 in that respect. It's very docile, but it doesn't, as you bring, you know, the nose has got to be way up in the air to stall it, or you've got to have a stick right back, but you don't really get a lot of buffet either through the controls or through the airframe. It's interesting that. Why, I don't know, no idea, but which is quite surprising, but there we are. So, but apart from that, stall was incredibly innocuous and docile. It doesn't drop a wing at all. It's incredibly kind to you from that point of view. And when it came to spinning tests, and initially obviously we're doing attempts to spin it with full forward CFG for safety reasons, well, for my safety anyway. I found that again with full forward CFG it's a bit like a K21. It might drop a wing if you really force the issue, but it just comes out again. So it's very docile. Mid CFG it will actually go into an incipient spin, but if you just keep the stick held back it just starts to go into a spiral dive and doesn't spin. So it's only with R CFG that it actually spins, which is fine. So from that point of view it's actually quite a good glider, certainly good for training because it will spin if you want it, rather like a K13, but if you don't want it to, it won't. You know, it's not going to bite you, but on the other hand, if you really push your luck with it, it will spin. So certainly with RCFG anyway. So spinning was the next thing. So eventually we got to do this whether we like it or not. Fortunately, it's not like spinning a type of completely unknown history, because we know that it was by the American Air Force approved for spinning. So, and it says that spin recovery is normal, however they measured that in the day. So off we go. So I put poor old Andy Aveling in the back as the crash test dummy, made sure the parachutes looked all right, went to 4,000 feet above the clouds, and after about 2 days when the tug got there, we decided to spin it, and obviously we're still here, so it did recover. Initial thing I had to do was just do one turn both ways and then report back to Howard and then go and do some more when he was happy, which we did. One of the things you've got to do in this CS22 that goes on forever, you've got to spin it with, recover with normal recovery procedure. Stick gradually forward in the centre, but you also have to do things wrong. In other words, try and make it recover. What happens if you try and recover and put the stick either left or right, depending on, you know, against the spin or into the spin, and do the recovery. So one of the things you've got to test, will it still come out, or does it do something nasty if you put hold the stick in the wrong place. Well, one of the spins I did, I inadvertently did that, which was spotted by someone, which is fine. But deliberately doing it, it very slightly affects the rotor rotation, but not much, but it actually doesn't have any effect whatsoever on the recovery, which is interesting. Doesn't slow the recovery or speed it up, doesn't do anything. But if you put interspin ailer on, it actually rotates just a little bit quicker. Surprising to me, because I thought it might do the opposite, but anyway. So very much like a K13, it spins really nicely if you pull it round a tight 45-degree turn and spin it off the turn, over rudder in the turn, stick in the back corner. It really flicks in nicely if you do that. The conventional sort of what I call the missionary position of spinning, just pull the nose up and put the rudder on. It will spin, but it's how shall I say, obviously going to do it. But you can make it flick if you deliberately abuse it in the turn, which is just it. So the spinning characteristic is incredibly similar to something like a K13, which is good because it means that it's safe, but you can spin it, which is nice. So from that point of view, it's probably quite a good training glider. Controllability, as I say, generally is fine. The control loads are a bit heavier than you might expect. Now, having said that, the elevator forces are not particularly high. The rudder loads are quite high, especially on spin recovery. You've got to stamp on it. And one of the reasons for that, I think the gearing is quite poor because you've got relatively small pedal travel, and if you remember that previous slide with the huge rudder, you've not got a lot of leverage, and you do sort of have to stand on the rudder a little bit. One of the other tests is obviously you've got to side slip the glider and abuse the controls, cross controls, all the rest of it. And again, to straighten the rudder when you're in side slip, you've got to really stand on it. The loads are quite heavy, so got to make sure the rudder cables aren't worn out. Yeah, you've got to stand on it. But it side slips nicely. It's a very good side slipping glider. Again, huge sort of side area on the fuselage, as if it doesn't come down quick enough anyway. If you want to get it down without the spoilers, it comes down like an absolute ton of bricks. And with full side slip and full spoiler, you can do almost a vertical descent, which is good. But there we are. So where are we going on? Sorry, I digressed a little bit. Oh, is that the end of my? Yeah, that's the end of that bit. Sorry. So really, the important thing is that then we have to submit this huge report, which is based entirely on that CS22, which goes into pages and pages, and that is harder than flying an aeroplane. Right in the report. It goes on and it goes on and it goes on. But then you submit it to Howard and he checks it and asks you a few questions, and now we're waiting for it to come back from the tech committee. But I think if we get the weight extension on it, which will be good, and if we can look at reducing the weights, I think it will be quite a useful glider for the GHC, and I think that hopefully we can fly it quite a bit. It's a very photogenic glider, I would say, and hopefully we can take it to some shows and things as well. But
you have plenty of volunteers to take it apart?
No, we fly it there. Yeah, if anyone lands in the field.
How many to de-rig and rig?
Oh, about 10. No, you need 5 people probably. But so, what else can I say? I don't know. It's
Parts of CS22 it didn't comply.
yes. Well, one of the things. Sorry, I should have mentioned that actually. the stall warning characteristics, but there are mitigating circumstances. If you read, in fact, I'll probably go back to that. If you read there, it says there are certain things that allow you, if not all of that is met, like recovery from the stall is prompt, both in straight and turning flight, which it is. You can correctly roll, and in fact the ailerons work right up to and during the stall. Amazingly, you can move the ailerons in the stall, and it's, if you hold it in a mushing stall, the ailerons work.
I think that's because they're slotted.
Yeah.
They're freeze ailerons.
Yeah, that's right. So they're pretty good. And the only one it doesn't, if you stall it in a 45-degree turn, that's all right, as long as you don't put the rudder on, then it will spin. So that, there are mitigating circumstances, but it did. One of the criteria is it should have some sort of stall warning buffet, which it doesn't seem to have a lot of. It's very hard to detect anything. What did happen on our VNE test, which we tested out a few times when we were spinning it coming out of the dive, is that because you have got to pull quite hard to get it out the dive, we found that the metal fairings where the wings join on started to vibrate rather a lot. That was quite scary the first time it happened, until we knew what it was. And I think there's some additional fairings which are missing, and I think we probably ought to put those on. That might help things a bit.
What is VNE?
Never exceed speed.
VNE is, sorry?
Never exceed speed.
Yeah, no, VNE is 98 knots. Yeah, max aero tow is 78 knots. So, but at 70 knots on the tow, it's beautiful. It's fine. So it's not a problem.
To be fair, I don't think any vintage glider would get through CS22.
No, not at all. None would. K13 wouldn't. But so there are some things which we couldn't even test on CS22. But surprisingly enough, quite a lot of stuff. It's. But we've got to have a yardstick to measure it by, and the BGA have got to be seen to doing this properly if they're going to issue a C of A on it. Apparently the next thing to do is the Spallinger, which is only ever going to get a permit because it can't get anywhere near this. Never get anywhere near this, because just the engineering side alone it won't. But as with the things like the Falcon, that's not got a C of A, it's only on a permit. Kestrel 22 is another one that's on a permit. Never did get a BGA C of A.
What sort of documentation for the glider is actually available?
Quite a lot, actually. There's a very comprehensive maintenance manual, or I call it erection and maintenance manual, which basically the Americans mean that's rigging, apparently. They obviously have different terminology over there. So that's very comprehensive. It's also got quite a comprehensive flight manual, but you do have to take some of that with a pinch of salt. I think there's a lot of optimism in that.
Sales manual, is it?
Sales manual, yeah, I think that's the word.
But,
Yeah.
but in terms of its design and it's the calculations that actually had
Nothing.
There was more information we could have got, but it was more parts, things like a whole bit of materials.
Yeah.
Didn't need.
No. But no, we haven't got anything on. What shall I say? Design criteria, which is the problem. Oddly enough, we have with the Spallinger, because there was a Swiss design criteria for gliders at that time, and there is a design criteria which it was built to, but we haven't got any. This was built to a military spec, obviously issued by the US Air Force or Army Air Corps. So.
Do you happen to know how the placard relates to WACO gliders, like the VNE and stuff?
No idea. No. Mm.
I think they like it fast.
Yeah, they were towed by twin-engine aircraft, which are at higher speeds, weren't they? But I guess they would have towed this behind a steerman or something like that in the day. But
So what was the longest flight you did?
I did one of nearly an hour soaring, but of course, you know, people start to get a bit annoyed if I stay up too long. But I could have stayed up all day on that occasion, but I was supposed to be test flying it, so I had to keep throwing the height away. But it's more economical to soar back up. That was my excuse anyway. And in fact, the last time we flew it, which was in October with Andy, when we did the spinning, we actually had a really good soaring flight late in October. We launched above the clouds, did all the spinning, came down, went under the clouds and went soaring for a while. And it was only the fact that we were getting quite a long way from Lasham, and I thought they'd probably cause a bit of an upset if we landed it in a field. So I came back. But as Andy said, it doesn't quite go as well as an Arcus, so we need to be a bit careful. But there we are. Any more trick questions?
Well, thank you very much, Richard.
Very good.
Nice to see you. So next month we'll have another talk, third Thursday in the month. Howard Tuoh is going to come and talk to us about Project Sigma, the industry associated with it.